Is it visible, sir?
Visible. Yeah, start.
Okay. My name is Saivardhan. I am going to present a topic on K-map. Basically, basically, K-map is a graphical representation of a Boolean expression. Basically, K-map is a graphical representation of a Boolean expression. It is developed by a scientist named Karnaugh in 1951. What is K-map? The K-map. Okay, sir. One minute. A K-map provides a simple, straightforward procedure for minimizing Boolean expression. This method provides a minimum expression, sir. Sir, 1 minute. My network is some problem. Is it okay, sir? Is it visible?
Visible. Just
Okay.
hide the share. Just
K-map is a
hide
made
the
up of.
desktop. Make full screen.
Oh, okay. Uh, A K-map is made up of 2 power and n number of cells. Each of the cells represents one of possible 2 power n possible product or some representation. It terms may be based on variables or n is a variable 2 power n. Wait a minute. Sir, is my voice is okay? Hello. Okay. Okay, sir. I am starting from beginning. Is it a problem in my network? Basically, K-map is a graphical representation of a Boolean expression. It is developed by a scientist named Karnaugh in 1953. A K-map method provides a simple, straight and forward procedure for the minimizing Boolean expression. This method may be regarded as a pictorial form of truth tables. Next, K-map. A K-map is made up of 2 power n cells. Each of the cells represent one of the 2 power n possible product or sum terms that can be from n variable. A variable map contains 2 power n of cells. That means 2 power 2, 2 power 3 based on variable. Each cell representing the 1 minute. Each cell representing the binary value of the input variable. The terms assign all the cells of K-map by labeling each rows and columns as is y and z. Here, uh, this is a two variable map based on this 2 power n. Sorry, based on the 2 power n, we get constructed this two variable K map. Uh, Here m0, m1, m2, m3 are different in all the variables due to this gray code here. Okay. This representation of K-map is 2 power n squares, squares or cells. It may be cells contains as per as truth table. Sir, is my voice is audible? Okay. There is some network issue. Okay. Is it audible still now? Okay. A K-map, by labeling each rows and columns, the map will be variable which contains some of the complements of the variable and some of the normal form. With this combination, as variable as complete, this product terms corresponding to this given cells
ఇక్కడే ఉంది.
corresponding to. Okay. So these are some rules of K-map. To be design a K-map, we have to follow these rules. We can each group should be larger as possible. That means we can group as much of larger as possible as here. This is example for largest group. Group may overlap. Two or three groups may be overlap on a single cells as like here. This is example of overlapping. Opposite group and corner grouping are allowed. These are some uh, we will use this point in more than four variable like a five variable map. We can use this here. This is example of five variable map. Here this 1 minute. Sir. Here here and these two are corner mapping.
వద్దు దగ్గరికి.
Don't care condition. Don't care condition. Here we represent the sum of SOPs and PO standard SOPs and SOP and POS in the K map. Only we will use standard SOP only due to all the sir, my voice is audible, sir. Sir, I will proceed after 2 minutes. My network is fluctuating. I will reconnect in. Okay. Okay. Don't care condition. Here we are used min terms as one and max min terms and max terms. Min terms and zero represented by one and max terms are represented by zero. Here we used also a extra term called don't care. It is represented by a term x. We will use as per our grouping. This don't care will be represent as one or zero. In this only as group only in grouping conditions. Okay. Implicant is a grouping implicant. At least grouping of cells is known as an implicant. We have two types of implicants: prime and essential prime. Prime implicant is a group possibility of grouping is known as prime implicant. Essential prime implicant means that means it should contain at least one number of single one in this group. I will show the example. Here, this is prime implicant. This is an essential prime implicant. Here, this green color. Are you visible, sir? This green color.
Yes,
Hello.
it's visible. Yeah, yeah. Yes.
This green colored is known as essential prime because it has outside one not covered with any other groups. It is known as essential prime. Prime implicant means covered maximum number of like this. This quad is a is presence prime implicant. N variable came up. We are using two variable, three variable, four variable, and five variable based on our requirement. This is built upon rows and columns with n number of cells. N is n number of variable. 2 power n two power 2 is also 4. We get 4 cells here. As like that, we can design a 3 variable and 4 variable and 5 variable cells. This is a 5 variable cells, 5 variable map. Okay. This is an example of two variable map. Here we have a equation of AB and it values are minimal equation is 0 comma 3. We Here 0 is represented in this first thing and 3 is represented here. Based on this equation, we have the both the input output. Y is denoted depends on both the inputs. Here row and column a comma b are used. So it labeled is a comma a bar and b bar. Here it is a into b. Final output is this, and as well as this is the output of X NOR gate. So this is the design of X NOR gate. This is example of three variable map. Here we are used minimum min terms as 0, 1, 2, 2, 3, 2, 4, 5. Here we represented here 0, here 1, 1, 4, 5, and 2. Here we can possibility of getting this corresponding ones as a quad, and one more we get this avails corner grouping. By this we get uh, in four variable we get as output as B bar and this corner grouping pair A bar and B bar. We get this final expression. This is the design of this circuit. This okay. This is the four variable map. As per this minterms, we grouped these all one quad and one corner grouping. This is the final equation evolved from this. This is the design of this final equation. Also here it is main for us. Here five variable map. Min terms are 0, 2, 4, 5, 6, 7 up uh, up to 7 and don't cares of 20, 21, 22, 23, 25, 26, 27 and 29. Here we use the two maps because of 2 power n terms. 2 power n it is 5, so we get 32 cells. We represent we labeled here of every cell as per gray code. Here we marked as these minterms and we grouped here. Here we have don't care. Here we can these two quads are corresponding lengths, so we can combine this as a octet that is also this corner grouping also allowed. Both the maps have this facility. Here also we get one octet and here also we get one octet due to corresponding cells. So for this we can this the final equation. This is drawn. This design is drawn as per this okay pairing and overlapping condition. Here this here two ones is paired. Two or more is known as pairing. Two or more ones is known as pairing. Here overlapping means here three pairs are overlapped at a single point here. This is overlapping condition. Quad four corresponding ones are grouped together is known as quad. Octet grouping here where availability of eight corresponding ones in two lines we can consider as this octet. Hello, are you is it
Yes, yes, yes.
hello?
Go ahead, please.
Yes, sir, is audible. Okay. Corner grouping here we use here also corner grouping as five variable also and this 16 cell map also. Mainly we have for suppose here we have all ones, so we can avail this corner grouping also here. This is known as corner grouping. Okay sir, that's it, thank you.
Yeah. Yes, it's a good presentation. Normally,
uh,
yeah.
Actually I am not present properly due to some network issues. I'm not satisfied with my presentation.
No issue. I have one doubt. You
Okay
have
sir.
Boolean algebra, no? Boolean algebra. Why you are going into K-map?
Sir, K-map is a fastest method to solve any Boolean expressions, sir. We have to follow many rules for the solving in Boolean algebra. We can find a fastest and easier method in K-map without following anything. Just we have to follow some rules. These are the
Okay.
rules to follow as
Yeah, basically Boolean algebra we need to apply, we need to remember
apply
rules,
sir,
all the
all
rules,
the rules.
and we need to like
It is
every
also a
time,
lengthy process.
yeah, lengthy process. Every time we are we are applying the rule. Every time we need to write the expression. Yeah.
Yes, sir.
So in order to overcome that, this is a graphical method.
We-
We dedicated to K-map. And one
Yes,
more
sir.
thing, we are using gray code sequence. No?
Yes,
I
sir.
know the reason why we are using gray code sequence.
Gray code sequence. Uh, I
Gray
noted
code
this point.
sequence. No? Yeah, 0, 0, 0, 1, 1, 1, 0.
Yes, sir.
No,
This
gray
gray
code
code
sequence.
sequence up to no, sir. This is
Yeah, gray code sequence.
the
Yeah, gray code sequence we are using. Then I know the reason for this gray code sequence. This one, this
yes, sir. We are use
top you are writing.
sir.
Top you are writing 0, 0, 0, 1, 1, 1, 1, 0,
Yes, sir.
0, 0, 0, 1, 1, 1, 1, 0.
Yes, sir. We
This
are used gray code. Yes, sir. Not I
Yes,
have not
why can't we
idea
use binary
about
and
that.
why we are using gray code?
Uh, I have bit.
Okay. I will tell you. Anyone have the idea about that? Why gray code you are using and why anyone? Anyone can respond and tell me why we are using in the gray code sequence in the K map. Normally, gray code is nothing but non-weighted code, and this is nothing but any distance code. Okay. So normally, if you see like 0, 0, 0, 1. So this is distance by how many bits? 0, 0, 0, 1. If you compare these two bits, please respond. It is distance by how many bits? One bit, no?
One
It
bit,
is
sir.
distance by one bit. A bar B bar plus A bar B. So if you take A bar common, B plus B bar equal to what? 1, no? You
Yes, sir.
understood? And next one you see 0, 1, 1, 1. 0, 1, 1, 1 means A bar B plus AB. So you can take B common, A plus E bar, that is 1. So B is, you are getting B core. A is eliminated. And next row you see, D is there, no? Okay, sorry, D is there. DE means what? DE plus DE bar. DE plus DE bar means, so which one you can take common? D common. You can take D common. And so E plus E bar equal to what? 1. So that means you are getting only D. So this gray code is a one, we can call a unit distance code, and we can call as a non-weighted code also. Okay, we'll discuss more about the codes. So this is one of the few questions we will ask, why gray code is used in a K map, and so that's why in order to minimization process, we need to, suppose if you are using binary in place of gray code, we can't minimize. Okay, so normally the binary what you will get 0, 0, 0, 1. Next what you will get 1, 0, no?
1-0.
1, 0. So that means
Yes, sir.
if you take this is nothing but A bar B plus A B bar. Anyone is minimizing? D bar E plus D E bar. I think it's minimizing, no? So in order to
Yes,
minimize
yes.
minimization process, we need to use sequence means gray code sequence. Okay, is it fine?
Yes, sir.
Yeah. Okay, nice presentation. Anyone having any doubt? Please respond.
No, sir.
Shivanand or Shrubi Yadav.
Sir?
Any
No, sir.
doubts you have in the KMAP? This
No, sir.
presentation? Huh?
No, sir.
Okay.